Animals have their own permanently attached means of keeping warm. Some, like these long-haired cattle, quite spectacularly so. Birds also have natural means of keeping warm, and indeed waterproof. While some have the added advantage of their own personalised coloured costumes. Mankind, on the other hand, has little natural to keep him warm, and even less in the way of colour. Early clothing for man was skins, and would include those from the wild mouflon sheep. All European domestic sheep have these as ancestors. Later, the wool from domesticated sheep would be used by man as the beginnings of the textile industry, even though it required some early ingenuity to transform fibres into yarns for the starting point of fabric and clothing manufacture.
In this video we shall first look at fibres as polymers, then natural fibres, regenerated fibres and synthetic fibres. Secondly, we shall look at yarns, spun yarns made from staple fibres up to 300 millimetres in length, and textured yarns made from continuous filament synthetic yarns. First then, the concept or idea of a fibre. I suppose that we all know intuitively what we mean by fibres. They are those fine hairy things like wool fibres, or the coarse coconut fibres, and the seeds of the wire clematis. The idea is in our mind that a fibre is very long in relation to its width. This length to width feature reflects their internal chemical structure. The molecules which make up the fibre are themselves very long in relation to their width. Some simple chemical molecules have the ability to link with themselves to form long chains which are called polymers. The type of chemical molecules, the number of such molecules joined together, and the extent to which the long chain molecules link sideways to each other dictates the properties of the polymer.
Some of the naturally occurring polymers are used in the textile industry as fibres, such as coconut used in matting, wool, cotton, and even wood. Cotton and wood are made primarily of cellulose, the prime constituents of all plants. From any particular wool fleece, there will be fibres of different length, and from two breeds of sheep, fibre length and thickness differ. The same is true of cotton fibres. Since cotton and wood are both made of cellulose, it is not surprising that a cotton-like fibre can be obtained or regenerated from wood. Wood, as compressed wood pulp, can be treated with chemicals to dissolve the original cellulose fibres. By extruding this solution through fine jets into another chemical, the new regenerated fibres are produced. One such fibre is viscose.
Over the last 40 years, a group of synthetic fibres have been developed and manufactured. These are built up from individual chemical units, usually derived from oil or coal, by a process called polymerization, usually requiring a combination of high pressure and temperature. Synthetic fibres are formed by extruding molten polymer through fine jets, stretching to reduce extension and increasing strength to give a series of thin, exceedingly long fibres called continuous filaments. This collection, and there may be from 1 to 150, is itself called a yarn, a continuous filament yarn. By varying processing conditions, including the size of the spinning jets, a wide range of synthetic filament thicknesses can be produced. By cutting or breaking regenerated and synthetic continuous filament fibres into smaller lengths, it is possible to produce staple fibres similar to natural ones.
In this second part, we shall look at the production of yarns. First, the spinning of yarns from staple fibres. Staple fibres, whether natural or synthetic, are spun into a yarn using the same basic elements shown by this hand spinning process. First, the fibres are teased and separated from the tangled mass, wool in this case, by a process known as carding. Note the special shape of the carding wires. This process also makes the fibres lay more parallel to each other. The spinning process consists of feeding fibres at a controlled rate and twisting them together to form a yarn. It is the twist causing pressure between the fibres that gives a yarn its strength. Up to a certain point, the greater the twist, the stronger the yarn. If a yarn is untwisted under the tension of a weight, the strength soon fails. There are a variety of spinning methods for converting staple fibres into yarns, but not all methods are applicable to all fibres. The common traditional methods of cotton, worsted and woolen spinning were developed for natural fibres. These methods have been adapted for the regenerated and synthetic fibres. Cotton spinning systems are designed for short staple length fibres, ranging from about 13 mm to 90 mm.
The worsted and woolen spinning systems are designed to take longer fibres and can cope with fibres of 25 mm to 300 mm in length. Using sample machinery, we can show part of the production process of worsted spinning. This carding process, using wire cards, teases the wool fibres from the raw washed wool. From there, it goes to a second stage where the fibres are further straightened. The next process begins the drafting or thinning down of the roving before transferring to the spinning frame. On this machine, the final drafting or thinning of the yarn is achieved and the full amount of twist is inserted. Finally, using an automatic cone winder, the yarn is wound from the spinning bobbin onto the familiar knitting cone. Woolen spun yarns omit much of the fibre straightening after carding, and hence a more hairy and bulky yarn is produced.